All right, let's move on to problem number 11. All right, so in this problem, we have the double-sided limit of a function, and it's set equal to a number. So, double-sided limit. What do we know? I don't know if there's a hyphen here, but double-sided limit. Something equals something, right? What is it? The limit, I should just say lim. The lim of the left is equal to the lim of the right-hand limit. And again, I do have the notation in the previous slide if we need to write that down. That might be in a different video though, I believe. So the double-sided limit means the left-hand limit and the right-hand limit are equal to each other, nothing more. So a graph that will prove that most of these are not the case would look something like this. So draw my y-axis, my x-axis, and here's my function. It comes up like this, and there's a hole in the graph, and it continues up like this. So notice in this graph, I have satisfied the conditions of setting up this problem. That is that the left-hand limit, that as I come closer to this direction, I approach some height, and that they're even calling it a number. It could be 4, but in this case, they're just calling it L. And as I approach it from the right-hand side, I'm getting to the same value of L. It doesn't necessarily mean I have to be equal to the point. That would mean it's continuous, but it just means that the double-sided limit exists. That's all I need. And this will prove that most of these don't exist. Okay, so let's take a look at A. F prime of A exists. So remember, if you have F prime, that means you're talking about the derivative. The derivative can only exist where it's differentiable. This graph is not differentiable. Go ahead and take a guess why this is not differentiable at this value of A. If you said that this is not differentiable because this is discontinuous or there's a hole, you would be correct. So it can't be A because I've just proven why this might be true. Remember, we're looking for something that must be true. Since this is a might, A is eliminated. Let's take a look at B. F of x is continuous at x equals A. Well, clearly not. I just told you that this is a discontinuity. There's a giant hole in the graph. So it's not continuous. It doesn't have to be, at least. It could be. So it's not continuous for this counterexample. Let's take a look at choice number C. F of x is defined at all x equals A. So my definition, my informal definition for defined, okay, that was some really bad handwriting. Let's try that again. Defined. Defined to me means when I plug in a value of x, so when I take a value, or I'm just going to say an x value, I can find a height. All right, so if I plug in x equals A, do I have something that's defined? Do I have a height? No. I mean, I could have drawn a dot right here to define it, but that's not necessarily the case. I didn't do that. It's not defined anywhere. There's no height when I plug in A. It's not defined. So, I mean, again, it always could be. This is always a might, but we're looking for something that must be. So this is a might. Let's take a look at choice D. F of A equals L. Translate this. What does F of A mean? If you said that's the height at A, you would be correct. So the height at A equals L, that is trying to say that there is a point here and it is equal to L, but go ahead and look at my counterexample. It does not have a height. It's a giant gap here, a giant hole in the graph. So this is not necessarily true, and the correct answer is E, none of the above. By the way, this is problem number 11, I believe. Let's check the last. This is problem number, yeah, so this is problem number 11. I forgot to label that. Let's go ahead and take a look at problem number 12. This is going to be problem number, whoa, what's going on? Computer's trying to catch up with me. Problem number 12. All right, so we're looking for something that is false here. So that means 3 of these things are true. All right, let's take a look at A. F is continuous at x equals A. Continuous. No, it's not. Look, there's a hole right here. Since there's a hole, it's not continuous. This is false. And remember, we're looking for something that's false. That's the answer. Let's just quickly go through B through D to understand why all of these are true. So x equals A is in the domain. Look, so that means that I can put A in and get a height. When I put A into my function, look, I get a height. It just happens to not be where I thought it might. It's jumped up here. There's a giant hole, and it still is in the domain, but it isn't where we thought it was. So this is actually true. All right. The left hand, oh, sorry, this is the right hand limit is equal to the left hand limit. So again, what does that look like? So the left hand limit is coming up here. I get to the height of this point. The right hand limit, I also get to the height of this point. Both of those are equal to each other. So this is also true. And finally, the double-sided limit of f of x exists. Remember the left-hand limit and right-hand limit have to equal for the double-sided limit. This is almost exactly saying what C is saying, that both of them are equal to each other. So if C is true, then D is also true. And we're done. Yeah, the answer is A. Let's move on to the next problem, problem number 13. Number 13. What is the, oh, look at that, average rate of change? Whenever you see that word, you should in your mind be immediately thinking of the formula of average rate of change. But let's read on of the function given by that on the closed interval. All right, well, we're going to need the formula anyway, so go ahead and recall. What is that formula? Think about it in your mind. What is it? And I'll give it to us right now. It is f of b minus f of a. All of that is divided by b minus a. All right, so what are a and b in this case? Well, it's the start and end of the interval. So a is 0, b is 3. I don't know what f of b is until I plug that in. So f of b means I'm plugging 3 in for 4. So f of b, this is how I'm calculating. I'm going to write this down here. F of b, this is the same thing as f of 3. And f of 3, that means I'm plugging in 3 to all of these values. So here I go. 3 to the power of 4 minus 5 times 3. And that's the end of the function. All right, how do we do this? 3 to the power of 4. I think that's 81. Oh my gosh, okay. I'm just going to double check because I don't trust myself. 3 to the power of 4, 81. Okay, just making sure. So I have 81 minus 5 times 3 is 15. So this value is 66. Make sure I did my math right. Good, okay. So I know f of b, f of a is going to be easy to find, everything else is easy to find. So let's go ahead and sub these in. F of b, I know f of b, this thing is equal to 66. So I have 66 minus f of a. That means I'm plugging a into the formula. That means I'm plugging 0 into this formula. When I plug in 0, you should see I get 0. And we know what b and a are. You just directly sub these in. 3 minus 0. This is 66 over 3, which is 22. So the correct answer here is C. 22. All right, let's go to problem number 14. 14. All right, which of the following must be false? All right, so that means that we have 4 things that are true. All right, f of a exists. Translate f of a. What does that mean? This means the height of a. Height of a, well, let's look at the height of a. When I look at a, boom, there's its height. Its height is right there. It does exist, and look, it's right there. So yes, it does exist. This is true, and we're looking for something that's false. A is not a possibility. F of x is defined for all of the values between 0 and a. So here's 0, and here's a. Is it defined between here and here? Defined, again, just means if I plug in an x value, I get a height. It looks like I get a height everywhere in there, so that is also true. Can't be B. We're looking for something that's false. All right, option C, f is not continuous. Ooh, okay, this is going to be a double negative, false and not continuous, so we have to be a little bit careful here. Let's just ask the simpler question. Is it continuous at x equals a? So at x equals a, is this function continuous? And you should hopefully say, no, it's not continuous. This is a hole right here. That arrow is not pointing at the right place. I'm going to point at the right place. That is a hole right there. It is not continuous. And this is saying it's not continuous, so that is a true statement. That thing was not continuous, and we're looking for something that's false. That is not a possibility. Let's take a look at D. The limit as x approaches a of the function. All right, this is, what is that? Is that left-hand limit, right-hand limit, double-sided limit? If you said double-sided limit, you would be correct. So that means that the left needs to be equal to the right. Does the height of the left, remember it's just f of x, not f prime of x, does the height of the x, height of the left-hand limit, height of left needs to be equal to the, okay, spelling, Mr. Sindel, come on, height of right. at least as it approaches that point. It's not of the entire left, but so the height of the left seems to be approaching the height of the right. They seem to be approaching this height right here. So I agree. It does exist because they're both equal to each other. They both approach the same height. So this one is also true. We're looking for something that's false. Therefore, E is the answer. This is false. But let's look at why. Why is this false? F prime of x. Translate F prime of x. What does that mean to you? If you said slope or slope of the tangent or derivative, all of those would be correct. The thing that helps us the most in this problem, since we're looking at a graph, is the slope. So what is the slope of the left? As I approach this hole, it gets closer and closer to, well, it's actually the same thing. The slope is entirely constant here, and the slope is always, let me write this down, the slope of the left slope is less than 0. That is totally incorrect, Mr. Sindel. It is greater than 0. It is a positive slope. Greater than 0. It is a positive slope. And what about the right-hand slope? Right slope. And again, we don't need to calculate it exactly, and this is just a great way to prove it. This one is less than 0. If one is greater than 0 and one is less than 0, all the way up until that point, they are not equal to each other. When they're not equal to each other, it does not exist. So this implies D and E. It does not exist. And it's saying here it does exist. So this one is clearly false, and that's the answer. All right, on to number 15. Number 15. We have a bunch of points on a table. All right, let's underline things that are critical to us in terms of our theorems. Continuous is critical, differentiable is critical, and closed. Okay, we have now unlocked how many theorems? Well, continuous means we can use IVT. Continuous and closed means we can use EVT. And differentiable means we can use EVT. We have unlocked all three theorems with these three statements. In fact, if you just have differentiable and closed, you'd unlock all three statements as well, because differentiable implies continuity. Anyway, moving on. So the table gives us yes, yeah, blah, blah, blah. Which of the following must be true? We're looking for true statements. That means 4 of these are false. The minimum value, the maximum value is a value. Okay, we don't know what this is. So don't know, because we only have points, because only points. And the logic behind this is, say I'm not going to do these values because that's going to take too much time, but say you have a bunch of points and they're like, oh, well, these are clearly all here. This one looks like the max. That might not be true, because what if between these two intervals it just suddenly decides to go up like that and then continue on with the normal pattern that you see? You don't know what happens here. It could go up and down like a sine wave a bunch of times, and we have no idea of knowing that. So it can't be A, it can't be B. Those might not be true because of this weird phenomenon in between the points. Let's look at choice C. F of x is greater than 0 for that entire interval between 0 and 4. This is saying what? F of x. Translate F of x. Remember, x is different than c. It doesn't mean some point. It means all points. So the height of all points is greater than 0. I mean, the height of all these points is greater than 0, but that doesn't necessarily mean that all of the points are greater than 0, because again, in that same scenario where I had a bunch of points that were positive, you don't know that in between the first two, it suddenly doesn't dip down and go through the rest of the points. We don't know that the height is always greater than 0, so cross out C. I assume that a lot of us were able to narrow it down between D and E. F prime of x is less than 0. So the derivative of the function is less than 0, or the slope of the function is always less than 0. And notice here that the interval has been changed. We're now starting at 2 to 4. So this is the interval. Okay, it's not a bracket, it's actually a parentheses. Between 2 and 4, that's the interval that we're looking at. And it's saying that the slope is negative. And it is going down, 4, 3, 2. The slope is negative, but for the same phenomenon that happens here, we don't know what happens in between the points. If I have a giant sine wave in between the points, it definitely has a negative slope 1, 2, 3 times, or 4 times. It could have an infinite number of times between those points. Maybe not infinite, but definitely countably infinite, maybe. That also might be true. Okay, tangent, coming back to the problem, this is also not true. That means the answer is E. Let's take a look at this. There exists a C such that f prime of C is equal to 0. Notice that 0 and 4, this is the entire interval, and f prime. Every time you see f prime is equal to something, you should automatically think of what theorem? If you said mean value theorem, you would be correct. Mean value theorem does guarantee derivative. We are allowed to use it because differentiable unlocked at mean value theorem. Now, how do we know for sure that it does equal 0? I mean, obviously all 4 of the other ones were not correct, but to double check to make sure it does indeed equal 0, we have to actually find something. We have to calculate And you should be thinking here, calculate the average rate. What is the average rate? And when you hear the word average rate, you should automatically think of the formula f of b minus f of a, all divided by b minus a. And if you have been watching all of the other videos, or if you've been paying attention to the little snippets that I have in class, I said if the height at the beginning and end are the same, you know that the average slope is 0. That's the same thing graphically as this. I start here, I go here, here, have a bunch of random points, I don't care where, and at the end, I have this point. And remember how we drew these lines? We just connected start to the end. The average slope here is 0. That is a slope of 0 when I have a horizontal line. So this must be true by mean value theorem, since the average rate is equal to 0. All right, that's problem number 15. Let's go on to problem number 16. So this is problem number 16. All right, we're given this function, and we're trying to find the limit as x goes to 2. All right, so this is a double-sided limit. There's no plus or minus here. So we need to make sure that three things are, wait, no, we're only looking for two things. It's not continuous. It didn't say it's continuous. It's just saying we're trying to find the double-sided limit. So to check double-sided limit, we need to check that what two things are equal to each other. I already started writing, but think what two things are equal to each other. The left is equal to the right. And technically, the limit of the left is equal to the limit of the right. So I need to make sure that the limit of 2x is equal to 2 natural log of x at this suspect point. So what are my steps? I'm going to plug in the suspect point and set these two equal to each other. Let's do that. So plugging in my suspect point, natural log of 2 times 2. I guess all of that is in the natural logs. It wasn't super clear from the problem. And that needs to be set equal to the right-hand side as I plug in the suspect point, which is 2 natural log of 2. And obviously this side, natural log of 4 is equal to, So you might be saying, Mr. Sindel, this does not work. When I have left and right that aren't equal to each other, it's non-existent. And if that was the case, I would say yes. If the left and right are not equal to each other, this is a DNE. Go ahead and choose non-existent. But remember our rules of natural logarithms, and logarithms for that matter, because they're both the same rule. And I'm going to do this rule with logarithms. Say you have the natural log of a, and this a is to the power of b. This is the same thing as b times the natural log of a. This b can come up to the exponent, or it can come down in front of the natural log to be a coefficient. It can switch spots. So what does that mean? That means that natural log of 4, and let me move all this stuff over really quick because I need, oops, not like that. Okay, come back, Mr. Sindel. Grab the arrow, there we go. Move this, oh my God. It's so nitpicky. That means that natural log of 4, I can rewrite this as natural log of 2 to the power of 2, and this 2 can come down in front of the natural log. So I have 2 natural log of 2, and again, the right-hand side stays the same, which is 2 natural log of 2. Since both of these are equal to each other, it's the limit, the double-sided limit for that matter, is equal to this number, which is 2 natural log of 2. The correct answer here is D. Let's go to problem number 17. Almost there, guys, almost there. 3 more. All right. Well, 4 including this one. I kind of lie. 17. All right, so what do we have? We have a continuous function. All right. Closed interval. That's unlocked 2 theorems. What 2 theorems do we unlock? You don't really care because we are already told that we are going to be using IVT. By the way, the correct answer was IVT and EVT. So we know IVT guarantees what? So again, what does IVT guarantee? What types of things? Does it guarantee slopes or max and mins or heights? What does it guarantee? IVT, this is going to guarantee heights. All right, so let's look at A. It says f of 0 equals 0. Translate f of 0. What does that mean to you? If you said the height of 0 or the height at x equals 0, you would be correct. So this is saying that the height at x equals 0 is 0. So you might be thinking this is true because the values of the y's go between -1 and 3, and 0 is included in there. But IVT only guarantees that it happens. It doesn't say that it will happen at a certain point. So this one is a might be true. This is not necessarily guaranteed because we don't know exactly where it happens for the value of x. Let's take at choice B. It says the f prime of c is equal to 4/9. So f prime of c, translate that, and then also be thinking, what theorem does that make you think of? All right, translation, the derivative at some point, or the slope of the tangent at some point, and the theorem that it makes you think of should be mean value theorem. All right, so we don't know if this is going to be equal to 4/9 until we calculate, oh wait, never mind. This is f prime of c. We're only using IVT. We might think, oh, MVT, calculate average rate, but no, it says we're just using IVT. Don't even worry about it. This could only be true by MVT if it was equal to the average slope. I'm not even going to check. It might be the case, but it's not differentiable, and it tells us we're only using IVT. So don't worry about B. All right, C. What is this saying? Translate this part right here. This part says that the height of all values are between -1 and 3. The height of all values are between -1 and 3. And you might be thinking, oh, IVT, yeah, guarantees heights, and it doesn't restrict the heights, though. It just says that it passes through at least those heights. This is restricting the height, saying, hey, so there's a stop sign at -1. If I have a graph, here's -1, and here's, what do we go up to? Up to 3. You have to stay in between there. You're not allowed to go out, and we can go out with IVT. We're not exactly sure. So this one is a might be true. This is a might. And probably not. I wouldn't say probably. I don't know enough mathematics, but it's a might. So that one's not true. All right. You might be choosing between D and E right now. You are choosing between D and E if you're watching the video, and you're trying to figure out what the heck is the difference here, because f of 1, or the height at some point is equal to 1 and the height at some point equals 0. Aren't both of those guaranteed by IVT, since IVT goes between -1 and 3 and 0 and 1 are both in between that interval? You are correct in that respect. Both of these are guaranteed within the interval that it gives us for x. What interval does it give us between, or what is the interval of x values that we're allowed to choose from? The x values between -3 and 6. So this is the correct interval of x values. So this is correct interval of x values. This guy, however, that's the interval of y values. We need a correct interval of x values. So this one is incorrect. We're looking at D for the correct answer. All right, let's go on to problem number 18. Here we go. 18. We have the limit as x goes to positive infinity. So immediately you should be thinking of a few things. The two things that I always want you to think of are horizontal asymptote. Horizontal asymptote is always going to be the case when we're doing limit as x goes to positive infinity. The second thing that you should be thinking of are the type of rules that we use with infinities. Types of rules are top-bottom rules. So there's 3 rules to remember there. All right, hold on here. Got a phone call. So here we're going to use our top-bottom rules. And how do we translate this? I mean, we haven't really seen something 1 over 2x. How is this going to work with our top-bottom rules? Let me go ahead and rewrite this problem so that I have this in a more reliable form. Remember, we're looking for the term with the highest degree. So here's the problem written in another form. X goes to infinity, and the numerator is going to be x minus 1/2 x to the -1. Remember, if I have an x in the denominator, that's the same thing as x to the power of -1. So try applying that logic to the denominator. 2x plus 1/6 x to the -1. And again, we're looking for the coefficient, not the coefficient, we're looking for the highest degree. That means the exponent with the largest number. And these are both an invisible 1 here and a 1 here. 1 is higher than -1, so don't worry about those values. Go ahead and just cross them out. It does not matter. We only care about these values on the left. All right, and the degree is the same in the numerator and the denominator, which means we're in case 3, we're using a magic fraction. All right, so magic fraction here. Magic fraction means we're taking the coefficient of the numerator and the coefficient of the denominator. This coefficient, by the way, is 1 because there's an invisible 1 there. So the answer here is 1/2. The correct answer here is D. All right, let's go to, oh, I forgot to label this problem too. This is going to be problem number 18. Oh, I did label it. Problem number 19 is here. 19. We have two more problems, 19 and 20. All right, so this graph is closed. I underlined all keywords that let me know what theorem I'm using. Is closed on the figure shown above, show f, or if f is continuous, so underline continuous, and differentiable, underline differentiable. We have unlocked all three theorems. Then there exists a C such that, okay, so we're looking for things that are true, and it even gives us the graph up here. So f of c equals 0. Translate f of c equals 0. What does that mean? This means the height at some point is 0. That means it crosses the x-axis. Well, I don't know, guys. Does this function look like it crosses the x-axis? It does not. That's not the case. Remember, it could be true by IVT if the range of the y values included 0, but it does not. All right. Let's look at choice number B, or choice letter B. F prime of c is undefined. All right. So where is a derivative undefined? Where is it not okay to have a derivative? There's 4 places, and you need to memorize these. So I'm going to go ahead and list them here. First place is sharp corners. Sharp corners. Place number 2, discontinuities. Discontinuities. Place number 3, we have a vertical tangent. I'm doing this out of order, I'm sure. And number 4 is endpoints. I think maybe we had endpoints before, vertical tangent before, but do we see any of those 4 things in this graph? Or is there any evidence of it in this problem? The answer is no. If there's none of these bad things, it's always defined. So it is never undefined. Can't be that. We're looking for true things here. All right. All 3 of these choices have f prime of c. F prime of c is guaranteed by which theorem? Which theorem says, hey, we're talking about derivatives. Hey, we're talking about slopes of the tangent. If you said MVT, you would be correct. Can we use MVT? Yes, because it's differentiable. And finally, we need to calculate what? What is the thing that you calculate with MVT? If you said average rate, you would be correct. And now go ahead and calculate the formula. What is, or recall the formula. Formula for average rate is, I'll go ahead and write it down, f of b minus f of a, all divided by b minus a. So let's go ahead and calculate that. Remember that the f of b, or the y value, is the second value. So those are going to be the ones you do first. I'm going to go ahead and arbitrarily say this is b and this is a. So f of b is going to be 2. F of a is going to be 4. So this is going to be equal to 2 minus 4. On the bottom, I have 7 minus negative 3, or 7 plus 3. Oop, that's going to be a 3. I can change that. And this is going to be equal to negative 2 over 10, which is equal to negative 1 over 5. So that is the average rate. Hopefully you can tell that's a negative 1 over 5. This is the average rate. Which one of these is the average rate? Boom. D. Done. True by MVT. All of these 3 have a wrong slope. It's only guaranteed that it's equal to the average rate of change. And the average rate of change is negative 1/5. All right. Final problem. Number 20. We're almost done. Here we go. All right. Which of the following has the greatest value? Greatest value. Okay, this looks like a very similar problem to the homework that we've had. The homework basically said, draw tangent lines at each of these points. That's what I want you to do. Each of these possibilities, draw the tangent line and figure out what the heck is going on. So I'm going to do my best to draw a line here, and I don't know if I'm going to be able to use technology to do this correctly. So f of a. F of a isn't really a tangent line, so that's just a height. F of a is negative, though. So I'm just going to go ahead and write here, f of a is down here. This is f of a. This is negative, so I'm just going to say less than 0. F prime of a, that's actually talking about the derivative, the slope of the tangent at a. So let me go ahead. I think I'm going to try to sketch this. If it doesn't work, I'm going to try to draw a line. So f of a, it looks like this line. And of course, I'm not very good at drawing it. Let me try using technology here. It might fail miserably. That actually looks pretty good. So that is the slope of the tangent at A. And you can clearly see that this slope, is it positive or negative? It is positive. So I'm going to go ahead right here. This is greater than 0. It is positive. If you don't like doing greater than 0 because it confuses you, just go ahead and write positive. let's go ahead and look at f prime of c. C is right here, and again, I'm going to use my line. I think this one should be pretty straightforward. Okay, well, it didn't go through the line, but luckily technology, you can move lines. Haha, it's a perfect tangent. This is f prime of c. The slope of the tangent at c is, what's the slope of this line? Slope is equal to 0. It is 0. All right, and again, we're looking for the greatest value, so be thinking of that as you're calculating all of these. F of d minus f of c. Remember, f of d, this is the height at d, and this is the height at c. So the height at d is negative, and it's subtracting the height of c. Or sorry, the height at d is not negative, but you're going to get a negative answer because f of c is bigger. This guy is bigger, f of c, because the height is taller than the height of d. So this whole thing is going to be negative. When you take something smaller and subtract something bigger, you get a negative, less than 0. And finally, this guy might look a little bit confusing, but he was in the homework. F of b minus f of a over b minus a. What is that? That is average rate. And how do we graph average rate? We connect two things. Do you remember what they were? The average rate, you connect the starting to the end, and the start is usually the second point, and the end is b. It doesn't really matter. You're going to draw a straight line anyway. So draw a straight line from a to b. And again, using technology here, b goes to this point, and a comes to this point. So this one is also greater than 0. Okay, we're looking for the one that's the greatest. So this one is negative, not true, equal 0, not true, less than 0, not true. Okay, we're down between E and A. Both of those, wait a second. Oh my God, did I make that error? I apologize, guys. I'm supposed to say greater than 0, and I wrote less than 0. Wait, no, I had that right. What am I doing? I'm tired. Let's just undo these really quick. Okay. Blah, 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 restart. All right, so things that are negative get crossed out. This one was positive. Okay, I crossed out all the negative ones. So I'm left with two positive answers, B and E. Notice that the slope of this line right here, the slope of the tangent, and the slope of this secant line, those are the two slopes I'm comparing. So which one of these looks like it is steeper? Which one is steeper? And I agree that it is really hard to distinguish because they're really close, but the one that's steeper is B, the f prime of a. And I can prove this mathematically, but we haven't learned how to take the derivative yet, so you're just going to have to go ahead and graph it and look at what slope is bigger, or what slope is more steep. All right, that concludes all the answers for the practice unit test for, the practice for unit test 1. All right, if you have any questions, text me, call me, do whatever. Study with a friend, go over the homework, test us tomorrow, be ready. All right, see you guys later.